So you've got this amazing product idea, right? But now comes the really tough part. How in the world do you actually make it? If your part is plastic, you're suddenly staring down a bunch of choices. Injection molding, blow molding, rotomolding. It can feel overwhelming. Each one has its own rules for cost, complexity, and how many you can make. Well, today, we're going to build a simple framework to help you cut through the noise and pick the absolute perfect process for your project. Here's how we're going to do it. First, we'll get into the nitty-gritty of how these processes actually work. Then we'll talk about what you can realistically make with them. After that, we dive into the all-important money question, cost versus volume. We'll also touch on picking the right material, and finally, we'll wrap it all up with a simple guide to help you make that final call. All right, let's start at square one. Before you can even think about choosing, you've got to understand the fundamentals. How do you go from a pile of plastic pellets to a finished part? Because the how of it all is what determines what's even possible in the first place. Okay, think of injection molding like a super-powered water jet, but with molten plastic. It takes melted plastic and shoots it into a tightly sealed two-sided mold under incredible pressure. This method is the undisputed king of creating solid, dense parts with unbelievable precision. So if your design needs super tight tolerances, you're almost always going to start by looking at injection molding. The secret sauce here is that crazy combination of force and precision. We're talking about a steel mold clamped shut with tons, literally tons of pressure, while hot plastic fills every single nook and cranny. Then it cools down just right so the part solidifies perfectly. That's how you get millions of parts that are all absolutely identical.
And yeah, this is the kind of heavy-duty machinery we're talking about. These things are beasts, built for extreme pressure. Just that two-sided steel mold can be a massive investment. But that's the trade-off, right? It's what makes it possible to churn out parts for pennies a piece when you're making millions of them.
Next up, blow molding. Honestly, the easiest way to picture this is just blowing up a balloon inside a bottle. You start with a hot, droopy tube of plastic, they call it a parison. You clamp a mold around it, and then you just inflate it with air. Poof! The air pressure shoves the soft plastic against the mold walls, and you've got your shape.
Now, the big difference here is that it's air doing the work, not some massive mechanical press. And because the forces are way, way lower, the molds can be made from cheaper stuff, like aluminum. That brings your upfront cost way down. It's absolutely perfect for hollow, thin-walled things, like bottles, containers, and tanks.
And now for something totally different, rotational molding, or as most people call it, rotomolding. Forget high pressure entirely. This process is all about centrifugal force. You take some powdered plastic, dump it into a hollow mold, and then you heat it up while spinning it around on two different axes, kind of like a rotisserie chicken. This process is really more like baking than anything else. As that mold tumbles around in the oven, the powder slowly melts and just evenly coats the inside walls. What you get is a seamless, hollow part with super uniform walls and, this is the key, almost zero internal stress. And that lack of stress makes the final product incredibly tough and crack-resistant. It's why it's the #1 choice for things like kayaks and huge industrial tanks that need to take a serious beating.
Last but not least, we have thermoforming, which is probably the simplest of the bunch. Just imagine taking a warm blanket and draping it over a chair to see its shape. That's pretty much it. You take a flat sheet of plastic, heat it until it gets soft and floppy, and then you use a vacuum to suck it down onto a single-sided mold.
You probably noticed two huge differences here. One, you only need a single-sided mold. Two, you have to trim the excess off at the end. That single-sided tool is a game changer. It makes the tooling way cheaper and a lot faster to make. Once you have the shape, you just trim away the extra plastic from the original sheet. And you can see that simplicity right here in this picture. You've got the heated sheet of plastic up top and the single mold sitting right below it. There's no complex, high-pressure two-part system. This is exactly why thermoforming is famous for getting products to market fast with a really low barrier to entry. Okay, so we get the basic mechanics now, but what does that actually mean for your design? The shape and geometry of your part, is it hollow or solid, simple or super detailed? That's the next big filter we have to apply to find the right process. And this is really the fundamental choice you have to make. Are you making a pretty straightforward hollow thing, like a bottle or a fuel tank, or are you designing a really complex, solid piece with all kinds of little features like ribs, mounting bosses, or snap fits? The answer to that question is going to point you in one of two very different directions. This picture really says it all, doesn't it? Over on the left, that's injection molding's happy place. Solid parts with tons of complex details, like little gears or internal supports. Then on the right, you've got a classic thermoformed part. A big, simple panel. It's fantastic for making the outer shell of something, but you just can't get all those tiny molded-in features.
Okay, time to talk business. This is where the rubber really meets the road. It all comes down to the economics of it, right? You have to balance that big, scary upfront cost for a tool against the long-term cost you're going to pay for every single part you make. So let me ask you straight up, what matters more for your project? Do you need to get started with a really low initial investment for maybe just a few hundred parts? Or are you planning on making tens of thousands of these things, where saving even a few pennies per part is going to add up to a whole lot of money?
This table lays out that core trade-off perfectly. Just look at how they're complete opposites. Injection molding has by far the highest tooling cost, but it gives you the absolute lowest price per part. And thermoforming, it's the exact reverse. It's super cheap to get started, but each individual piece you make is going to cost you more. So you're either paying up front or you're paying as you go.
So where's the tipping point? Well, the general rule of thumb is right around here, between 3,000 to 5,000 units. If your total production run is going to be smaller than that, the low tooling cost of thermoforming usually wins out. But as soon as you cross that 5,000 part threshold, the massive per part savings from injection molding really start to take over and make it the smarter choice.
Of course, none of this matters if you can't use the right plastic for your part's job. Choosing a material isn't just about what color it is. It's about strength, chemical resistance, how it handles heat, and, critically, whether that material can even be used with the manufacturing process you want.
And the material options vary a ton between processes. Injection molding is the most flexible by a long shot. It can handle almost any engineering plastic you throw at it, even cool, sustainable biopolymers like PA11. Blow molding is more tailored for things like HDPE and PET, but rotomolding is the real specialist here. It pretty much only uses polyethylene because that slow, gravity-fed process needs a material that melts and flows super easily without any pressure pushing it. All right, we have covered a lot of ground. We've talked mechanics, geometry, cost, and materials. So now, let's pull it all together. Think of this as your final cheat sheet, a way to weigh all the factors and make a decision you can feel really good about. This chart is your new best friend. Here's how to use it. If you need a ton of parts, we're talking over 5,000, and they need to be detailed and solid, bite the bullet and pay for injection molding tooling. The per-part savings will be huge. For high-volume hollow parts, blow molding is your champion. Now, if you need large, super durable hollow parts but in lower quantities, rotomolding is that perfect sweet spot. And finally, if you need to get to market yesterday with just a few hundred or a few thousand parts, nothing beats the speed and low startup cost of thermoforming. So there you have it. You have the framework. You can now map your project's needs, its shape, its volume, its budget, directly to the right manufacturing process. The trade-offs are clear. So the only real question left is, what are you going to go create?